Alright, similarity part 2. So, number 6 says, in each pair of similar triangles, use appropriate proportional relationships to solve for the indicated values. Show your work. So the first thing wants us to solve for x. You could draw this as two small triangles and use proportions, or two separate triangles and use proportions, or you can just look at them separately. So what I would do to solve for x is x goes with 17, because x is from the small triangle, okay, and 17 is from the large triangle. Now the large triangle, we're going to use x is from the small triangle, so 4.8 is what I'm going to use on the top of the second proportion, and that's going to go with not 11.2 because we didn't use a piece here, we're using the whole thing, so we have to add those two together. So 11.2 plus 4.8 is 16. So that would be the other side of that proportion. So if we cross multiply, I get 16x equals 17 times 4.8, which is 81.6. Divide both sides by 16. X equals 5.1. Okay, so then to solve for y, you can do it by part to part or whole to whole. I would, for that one, do piece by piece. So I would do like 4.8, and there's different ones you can use, goes to 11.2, piece to piece, as 3.3 goes to y. And I would cross multiply. So I'd have 4.8y equals 11.2 times 3.3, which is 39 or 36.96. Divide by 4.8. Y equals 7.7. For number 7, let me erase some of what I've done. All the marks I've gotten everywhere. For number 7, we need to find x, and we need to find the measure of ni. So we have two separate triangles here. This is one of them, and then this one right here. And that did not save for me. There we go. Save. Alright. Is it one or the other? Okay. So, to find x, I would do x plus 2 over 9.2, small triangle on top, big triangle on bottom, equals 3.7, I believe, goes with the 14.8. If you look at the triangles, it looks like it's been rotated. So small triangle would be 3.7 over 14.8. We would cross multiply. So 3.7 times 9.2 is 34.04. And then we would have 14.8 times x plus 2 in parentheses. So we can just divide by 14.8 instead of distributing it out. So we get 2.3 equals x plus 2. Subtract 2 from both sides, so x equals 0.3. Okay, now for the measure of ni, that is this side length right here, that's going to correspond with the side length of 4.6. So I would put Like if we wanted to call this y, and I be like y because we've already used x. Like, so 4.6, and you could do the proportions differently. This is just one way. 4.6 over y, small triangle over big triangle, equals 3.7 over 14.8. So I'd have 3.7y equals 14.8 times 4.6, 69.08, and then divide by 3.7, and I would get 18.4 for the measure of NI. Okay. I'm gonna erase this. The next one says, which statement would justify that triangle ACE is similar to triangle BCD? So we're looking at the big triangle versus the small triangle. Alright, so this one being similar to this one. Alright, now if you look, they both share an angle. So this one's going to be congruent in both of them. Alright, if we can prove that the sides are also proportional, we could use side angle side. We don't know anything about any other angles, so we can't use angle angle. So I could cross off A. So, and we don't know anything about the third side, so I can't use side, side, side. So it's either going to be B or D. So we need to see if the sides are proportional. You can do part to part, whole to whole. It's completely up to you. So I could look at it as 7.5, and there's many different ways you could write this proportion. This is just how I'm writing it. Over 8.75 equals 3 over 3.5, and then let's see if that's proportional. You can cross multiply to see if they're proportional. You could simplify both fractions. It's completely up to you. If I cross multiply, I get 7.5 times 3.5. That's, if I go this way, that's 26.25. And then 8.75 times 3 is 26.25. So that means the sides are proportional, so they are similar by side angle side. Okay? And I'm not going to go over the last one because that one's a little bit more difficult, and I don't think that that's a level we need to get into right now. All right.